Now we are going to change our approach slightly. We've been working with direct variations. We've been able to calculate our unit rates, our slope, and our constant rate of change, understanding that a direct variation means we have a relationship that travels through the origin, and we have a relationship where all of its coordinate pairs are can be put into ratios that are equivalent. So now what are we going to do? Well, now we're going to try and compare direct variations. Okay, so we're going to use tables, graphs, words, or equations to compare proportional relationships. So it's very easy to compare two lines on a graph, right? It's very easy to compare two equations, but can you compare an equation to a graph? Are you able to compare a word problem to a table? Okay, this is a little bit more of a challenge. So let's try that now. Here we have a situation where we have a grizzly bear and a rabbit. We want to know which one can run faster. All right, everybody has their ideas, everybody has their philosophy. Okay, so that would be example 3 on page 192. We have a grizzly bear and a rabbit. Okay, so what am I going to do? I need to find the unit rate or the slope in each situation. How do I find the unit rate or the slope from the graph? I can do a couple things, right? I can do rise over run. We're good at that. Change of y and change of x. Or I can take one of these points, right? I can take this point here and simply do y over x because I know that equals my slope. So I can do 30 over 1, and I know that this grizzly bear can run 30 miles an hour. Now notice, we would have gotten the same thing if we would have done rise over run. And we would have done the same thing if we would have taken the second point and divided 60 by 2. Okay, so the change in y over the change in x, the slope, the rise over the run, all right, they're all the same when it comes to a direct variation. Now, we know the grizzly bear can run 30 miles an hour. How fast can this rabbit run?
35.
All right, someone says 35. How do we know 35?
Because it says b equals 35 and b represented for the line.
All right, very good. So we think it's 35. Do you remember how when we take this relationship, all right, y over x equals our slope, that we can rewrite that, right? And I can rewrite it this way. And we said we know that this coefficient, this number here, the number in front of the x, represents our slope or represents our constant rate of change. So in this case, when I look at the equation of the rabbit, the 35 is the coefficient. So that means it is our slope or our unit rate. So the rabbit can run 35 miles per hour. The grizzly bear can run 30 miles per hour. So it looks like the rabbit is in luck because it can run faster than the bear. Question. Rabbits are really quick, don't you think? I got 35 because I'm starting to use the equations. I'm starting to recognize how to find the slope from an equation. And when I have an equation, the number that's in front of the x or in front of that second variable is the coefficient. That is our slope. So now we can actually just look at the equation and say, oh, the slope or the constant rate of change is 35 in a direct variation or in a proportional relationship. That's also our unit rate. So we know the rabbit runs 35 miles per hour. Yes?
So could you just do why didn't you just do 60 divided by 2?
You could have. That was one of the things that you could have done. You could have, well, 60 divided by 2 is 30, which is how fast the bear runs. The graph represents the bear. The equation represents the rabbit. So we're comparing them. Okay? Got it? All right. Let's look. Good question, Savannah. Let's look at another example. Here we have 2 arcades. Very creative names. Game time. Playtime games, okay? Now, here, they've already given us a unit rate. 25 cents per token. In a direct variation, the unit rate is the same as what? It's the same as the constant rate of change or the same as the slope, okay? So I know that this unit rate here needs to be compared to the unit rate up there. All I have to do is do some division. Now I know that cost is usually Y. The number of something is usually X. So as Savannah mentioned before, I can take any one of these pairs and just divide. So if I take this pair right here and do Y divided by X, which is 3 divided by 15, I get 0.2 or 20 cents. All right? So where is the better place to buy tokens? Well, at Playtime Games, it costs 20 cents for a token. Here it costs 25. So it's cheaper to get tokens at Playtime Games. All right? Go ahead and try the got it at the bottom of that page.